Hey guys, how's everything going? This is JSer. In this video, I'm going to try to solve 209 minimum size subarray sum. We're given an array of n positive integers and a positive integer s. Find the minimum length of contiguous subarray. Which sum is bigger and or equal to s. If there is none, return 0. I see. So the minimum, right? Okay. So like for example, we get 2, 3, 1, 2, 4, 3. We need to sum them up to 7. Well, 0 does not matter. Does not satisfy. This not good. This is 6, not enough. That's 8. Okay, we find one solution, but with this 4, so we don't need to put 4 in. There's no for the starting x2. This is already enough, right? So now we start 3. So we just remove this 2, and we got 3, 1, 2, which is it's 6. It's smaller. So for 3, if start at 3, we need to push 4 in, and it's gonna be 10. Another 4. For 3, there's nothing there's no more need to do. So we remove 3, and we got 1, 2, 3, 1, 2, 4. It's 7. Okay, so for 1, this is already 1, 2, 4 is already enough. 1, 2, 4 is enough. So actually we need to, there might be a smaller case, like a 1, 4. If this is bigger than 7, then there would be wait a minute. Like we get 2 and 2, 3, 5. Okay, 2, 3, 1. This is 6, not enough. 2, 3, 1, 2. So this is 8 is bigger than 7. So for starting x2, there's no need to do anything, right? We just move to next starting x, which is 3 and 1, 2. Is it possible that 3, 1 is already a possible combination? If it is already bigger than 7, then this should be already stopped, right? So it's not possible. So the only chance is this, because the 7, because this combination is possible because of the new added 2. So this is only possible chance, or this is possible, right? But for 3, this is 6, and not enough. We add 4. Now we are satisfied, and we should stop adding more numbers for 3, right? So we go to 1, 2, 4. This is already satisfied. So for 1, it should stop. This cannot be 7, because this criteria is matched by adding 4. So this could not be. Okay, so we remove 1, we got 2, 4. So from these, we can know this is a typical, like a sliding window problem, right? Sliding window problem. So let's see the minimum, right? Minimum. So min length equals infinity, and the current length, let current length equals 0, let current sum equals 0. So let's see. We need to the start and end, right? Let start equals 0. Let end equals 0. If that's the case, then we we need okay, where should we start? Start from the previous one. Okay, I say just start with previous one is -1 and n is -1, right? And then yeah, and then I would say start with -1, or think these as the starting index. Start this, end at here, end at here, start here, end at here, right? So start 0 and 0, start 0 and 0 is nothing. I think it's better we say start from 0 and end at 0, then it's 1. Okay. Okay. Well, if you start 0 and end at 0, then the current length would be 1, right? And the input, it might be empty. So I need to remove the invalid case equals 0, then we return 0. The main length, okay. Current sum equals nums 1. Let main length equals current sum. If it's bigger than is, then 1. If not, it's not infinity. If the first one is big enough, then I think we should return right away. So infinity should be the first. If nums 0 is bigger or equal to s, return 1. Okay. So now this is the start interval, and then we move them around. If while n is more than nums length, and yeah, while this is it, and made a mistake. Currentness start from this, but we haven't processed it yet. Yeah, I'm sorry. Start current length is 0, and the current sum is 0. Yeah. So we haven't processed it yet, and when we are meeting a new number here, it means we should add current length plus equals 1, and sum plus nums n, right? And then we check if current sum is bigger than the s or equal to s, then the mean length equals math mean. The length will be mean length and subtracted with start and plus 1, right? If it's bigger than it, then we should do what? You should not only update the mean length, but remove the next one. It means start, move to the next one. But this still might be enough, right? Be we should, maybe we could move it a little further. So I think we should use do while do update it and start one, and we need to update this sum also. So sum equals subtracted with num start, while current sum is bigger and equal to n. We will continue it. We'll do this continuously, yeah, until that current sum is not enough, like we did here. Okay, and finally we will return the mean. If it's infinity, it's 0. If not, it's 7. Let's review our code based on examples. First, to start at 0, 0, and the end is 0. It's okay. We update the length to 1, update the sum to 2, and it's not okay. So we move n to 2, another 2. Now we get 8, right? So it's bigger than it, and then we update the main length. Start move to 3, 3, 1, 2. Current sum was subtract with 2. Here's a problem. I should do subtraction first. And 3, 2, 1, got 7, 6. So we will stop here, and then we go to next 4. Next 4, there's sum. Okay, it's enough. Then we move 3, and then we got this. This current sum is 7. It's again. So wait a minute. Go to the current is 7, so we now update it with over 3, and now we got 2, 4, right? 2, 4, and finally we will move to the next 3. It's bigger, so it's 3, so update it. Now we get 4, 3, and then it's still smaller, bigger, and or equal to 7, so we update it. It should be, it should work. There seems to be I know what happened. I forgot to update the n. Cool. I think it should work, right? No? Why we output 1? 1, 2, 3, 4, 5. Let's see. Current sum 4. Increase this. 1 for 0, 3 for 1. Okay, we got 15, which is the last one. So it's bigger than s. We update it. Why we return 1? Okay, we locally start 0, 4, and then 15 with 1, 4, 0. This is 15. Okay, this 1, 4 is 14. Ugh, shit. I know what happened. This should be S. God. Okay, finally we get it right. Cool. So this is the sliding window solution. For the time, every time actually we will move the end further or move the start further, right? So there will no stopping for the interval. And the start one step, the end move to next step. So worst case I think will be 2n. This would be time. Space. We didn't use any extra space, so it's constant. So that's it. Hope it helps. Some about array. When we meet something like contiguous, then it's we just think about sliding window if it helps. Okay, contiguous sliding window. Okay, that's all. Hope it helps. See you next time. Bye bye.